ಬ್ರೇಕ್ ಆದ್ರೆ ಒಂದ್ಸತಿ ನೀವೇ ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ ಹೇಳ್ಬಿಡಿ. Okay, very good morning to all. Okay, so in this session we'll be discussing about naive Bayes classifier. Okay, naive Bayes classifier. See, the very first thing which comes to our mind and we need to know is this naive Bayes classifier is a classification kind of algorithm. So classification kind of algorithm is my first point. It comes under classification kind of algorithm. See, you have in supervised and unsupervised and semi-supervised as a broad area of machine learning. Within supervised machine learning, we have many types. Okay, what are all the types that we have in supervised learning? We have classification kind of problem, and also you have one is classification kind of problem and another one is regression kind of problem. So within your supervised machine learning, so this algorithm comes under your classification kinds of problems. See, for example, in classification kinds of problem, we have logistic regression. Second is we have naive Bayes classifier, and we have KNN, an algorithm called as KNN. You have studied in your data mining. Okay, what is KNN? K nearest neighbor algorithm. And also we have support vector machine, or we can call it as SVM. Okay, so these I'm just jotting down all the main algorithms which are involved in your classification kind of problem. So one is your logistic regression, second is your naive Bayes algorithm. Okay, naive Bayes, or I can call it as naive Bayes classifier. We have KNN and we have SVM. Okay, so for all these example, you need to know where exactly we can just apply these kinds of algorithm. Okay, so we have examples like your email spam detection. Okay, you have email spam detection. What is email spam detection? What is spam? What is spam? In your email, if you go to your Gmail, okay, you'll be having a folder called spam. What is spam?
Unwanted messages.
Unwanted messages. Okay, so those messages we don't want. Okay, we have a folder called spam. And we also apply these kinds of algorithm for speech recognition. Okay, so speech recognition is another example which we have. So these are you can just think of this whole algorithms which we can these are all the examples for which we can apply these kind of algorithms or techniques. So naive Bayes is one of the type of algorithm within your classification kind of problem in your supervised machine learning. So this whole algorithm will be discussing in your module 4. Okay, so is the concept clear?
Yes, sir.
So one is second thing is your what it is based on. It is completely based on your probability. In mathematics, you have studied the area of mathematics, that is probability. So it is completely deals with this concept. Okay, so probability. So if your fundamentals of probability is very much strong, you can just go ahead. This whole naive Bayes will be NB classifier will be easy. Okay, you can just understand how exactly your naive Bayes classifier works. Okay, so for this purpose, we will be discussing in today's discussion. Our discussion is confined on this your fundamentals. What are all the requirements that we need to understand the concept of naive Bayes? Or we need to first will go through the fundamentals of probabilities. So after understanding the fundamentals of probabilities, we'll start comparing what are all the concept which is applied or involved in naive Bayes. This is what the thing that we are ready to discuss. Okay, so first to start with, okay, I'll just go and search whatever the we get in your Wikipedia. I'll go just for Wikipedia. So first we need to know what is conditional probability. I'll just type conditional probability. Okay, so I'll just go with the Wikipedia definition. Okay, Wikipedia. Okay, see, if you are able to observe here, he has given a beautiful example with respect to your conditional probability. I'll be taking one out of example here. Okay, let's consider this particular example. Okay, I think you are able to see my screen. Yes.
Yes, sir.
Okay, okay. See, in this example, let's say I'll tell that my conditional probability in my own words. So let's jot down what is actually conditional probability. So that is probability of A given B. Okay, A given B is equal to probability of A, which is equal to small a, given B is equal to small b. Okay, I'll just come up with the same example. So we'll go with the example and then come back to this definition. So those who are not able to understand, let's see, just you listen for this example so that you can just compare with the example with this particular formula. Okay, so here if you can observe, let's read out the problem very much clearly. Okay, let's read out the problem here. So suppose somebody rolls two fairly six diced. Okay, there is a dice. You know what is dice? Okay, it's a usually when you want to play snake and ladder games, you will be using this dice, this kind of dice. Okay, you will just roll the dice, and here you have the points. So one side here you have 1 and 2 and 3 and 4, okay, and 5 and 6. Okay, so it is a six-sided dice. So we wish to compute the probability that the face up value of 1 is 2. Give the information of their sum is no greater than 5. Okay, so here die is having d1, that is d1 is one first die, d2 is having first die, d1 is having how many faces? It is having 6 faces here. d2 is having 6 faces here. Okay, these are all the possible combination of d1. These are all the possible combination of d2. Okay, so what he is asking? So compute the probability. The face up value of first one is 2. So d1 in d1. So in d1, he is only concentrating on this 2. What are all the values? Okay, so in 2 I have, if you just, I have just mapped like this. So if there is 1 and 1, sum of 1 and 1 is 2. 1 2 is 3, 1 3 is 4. So these value are sum of d1 plus d2. Are you understanding? Yes.
Yes, sir.
So in the same way, if you observe here, so table 1 shows your this whole example. So 6 possible combinations for die 1 into 6 possible combinations of die 2, that is 6 into 6, that is we have total possible combination of 36. How exactly? That is 1 1 1 comma 1, that is this value 1 1 comma 1. Next 1 comma 2, 1 comma 3, 1 comma 6, okay, 1 comma 4, 1 comma 5, 1 comma 6. Next after that 2 comma 1. Likewise it goes up to 6 comma 6. So this is my last. So totally I'm having here about 36 possible combinations of your dice. Okay, so in that 36, he is only concentrating on your die 1 in that 2. Okay, so it is only one combinations. So in die 1, I have 6 probabilities. Am I correct? So in die 1, I have 6 probabilities. Out of what is the total number of probabilities which I am having? What is the total number of probabilities? What is the total probability which I am having?
36.
36 is my total probabilities. So 6 is my probability of die 2. In that 6, he is taking only one probability. Okay, if I just divide this, it will become 1 by 6. Okay, so now let's come back here. So probability that, so for this it is done. Next, what he is telling? Please look here. He is telling table 2 shows that d1 plus d2 which is less than or equal to 5. I want all the values which is less than or equal to 5. d1 is here, d2 is here. If you sum this, my value should be less than or equal to 5. If you observe here, 1 plus 1 is 2. Here it is 3, 4, 5. I cannot go for 6. So I'll stop here. If I come to next row, 2 plus 1 is 3, 4, 5. I cannot go for 6. Here it is 4 and 5. Here it is 4. Okay. What is the total number of outcomes which it is having? The red blocks which you are observing here. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 possible outcomes out of what is the total number of possibilities within these two dice?
36.
It is 36. So 10 divided by 36 is the probability of d1 plus d2 which is less than or equal to 5. Are you people able to understand this?
Yes, sir.
Yes, sir.
Okay, let's move with the next example. Okay, let's move with the next example here. Okay, so I'll just take the third example now. Let's say we have table 3 shows that 3 of these outcomes d1 is equal to 2. Okay, he is telling only the outcomes with d1 is equal to 2, in which when d1 is equal to 2, you need to pick d1 plus d2 which is less than or equal to 5. Are you able to understand? So what is my condition? My condition is d1 is equal to 2. This is the first condition. In d1 is equal to 2, given. So this vertical column represents given values which is already there. Pick the values. What values you need to pick? d1 plus d2 is less than or equal to 5. Okay, now if you are able to understand this, okay, if you are able to understand this clearly, you can do this. So in d2 I'm picking the values which is less than or equal to 5. I have 3, I have 4, I have 5. I cannot pick 6 or 7 or 8. So what is the total number of outcomes which I am having here?
3.
3 is my outcomes. So 3 divided by what is the possible outcomes here? What is the possible outcomes which you can expect in your this example? What is my available given data here? D1 plus D2 is less than or equal to 5. What is my possible outcomes?
10.
10.
10.
How exactly? Out of these values, see, when D1 plus D2 is less than or equal to 5, what is the outcomes of this? It is 10. Okay. So here I have 10 values, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Out of these 10 values, I'm just picking exactly the values which are in there in D1 is equal to 2. Is there any doubts in this?
No, sir.
No, sir.
Okay. So here I can write probability of D1 is equal to 2 given. So this is given D1 plus D2 is less than or equal to 5. Okay, that is, I can write it as 3 divided by, that is total number of possible outcomes is 10, which gives 0.3. 0.3 is my probability. So I can just generalize this notation. See, I can just generalize this notation as probability of, please write down this, I can just write it as probability of A given B, probability of A given B is equal to probability of A is equal to small a, some value which is there, comma, a given value B which is equal to B. Okay, here my A and B, capital A is my capital A and capital B is my random variables, some variables which it will be changing, random variables. My small a and small b are the values which are assigned, values which are values which your A and B can take. A and B can take. You can just write it down like this. And this vertical value, we call it as given. Okay. So given on condition. So given on condition. So your probability of A, how do you just learn to read this whole mathematical equation in your English. So if you are able to read your mathematical English equation in English, there comes your understanding. So how do I read this particular, can anybody just read this whole equation? Can anybody just quickly read this equation? Please don't waste time. We'll go quickly.
Probability of A given B is equals to probability of A is equal to A or B is equals to B.
It is not or, it is given. It is given B is equal to B. Okay, so given means it is my condition here. So this is, okay, I can just read it as, okay, this write it as probability of A given B, which is equal to probability of, please observe here, I am taking all the outcomes from your B, right? So from B, I am considering your A. Am I right?
Yes, sir.
Yes, sir.
So it is probability of A intersection B. Can I write it like this? Divided by probability of B. probability of B. So this is your whole definition of your conditional probability. Conditional probability. Given there is one, what is your basic thing? Given your probability of B should not be equal to 0. If it is equal to 0, it does not mean. Okay. So did you understand this? So I can write here, this is the main definition of your conditional probability. I'll just read out once again. Please listen again. Probability of A given B. So in B data, I'm picking some outcomes, that is A, that is equal to probability of A intersection B divided by all the probability of B. Can we go further?
Yes, sir.
Yes, sir.
Next, okay. Next we have two things. That is my, we just came to know what is conditional probability. After this, my second fundamental is you need to know what is independent event, and mutually exclusive event. Okay, you need, if you are, please try to understand these two concepts. What is independent event and mutually exclusive events? Okay, so as the first we'll discuss what is independent event is. Okay, A and B, A comma B are said to be independent, when I will tell that it is independent. Okay, I can tell independent that probability of, please observe this, probability of A given B is equal to probability of A. So probability of B given A is equal to probability of B. If you understand this, you can tell that it is independent. How do you tell that it is independent? So given probability of A, I'm calculating this probability given B. So within B, I want to, using B, I'm calculating the probability of A, which is equal to probability of A. This whole formula, this whole equation, I can just, by looking at the equation, I can tell that your probability of A is not dependent on B. It is independent of B. Am I right?
Yes, sir.
Are you understanding? Please unmute yourself and let me know if you are not understanding. Okay. Your probability of A is not depending upon B here. Same way, here, if you observe here, probability of B given A, so your A is the given data, you are calculating B, which is equal to probability of B. It means that your the probability of value of B is not dependent on A, it is independent of A. Okay, so example, let us say we'll take up an example so that you can just understand this clearly. I have A. Let's say I have my probability of getting the value 6 in, you have a dice. Okay, in die 1 I need to get the value of 6. Okay, probability of see B, I need to have die 2 in which I need to get the value of 3. If, okay, please try to understand this. If I toss the die 1, I should get 6. If I toss die 2, I should get 3. If you observe this, I'll just write the probability definition now. Okay, independent event definition. Probability of D1 is equal to 6, given d2 is equal to 3 is equal to probability of d1 is equal to 6. What does it mean? Your d1, see, d1 is nowhere connected with d2. Okay, di1 is different, di2 is different. If there is any given di2 here, d1 is not dependent on di2. Likewise, can anybody just tell me how your b is independent? Can just tell me for the same example?
Probability of D2
Probability of
D2
d2
is equal to 3
3
given
hmm,
D1 is equal to 6
hmm,
is equal to probability of D2 is equal to 3.
exactly. Okay, so what does it mean? d2 is not dependent upon d1. Did you guys understand? Can just anybody let me know whether you have understood this concept?
Yes, sir.
Independent events. So this is my second fundamental. You need to know what is independent event and mutually exclusive events. Okay, now let's assume we shall try to know what is mutually exclusive. Okay, mutually exclusive. Okay, mutually exclusive events. So what is mutual? Let's go ahead with the definition. Probability of A given B, probability of A given B is equal to probability of B given A is equal to 0. Okay, so both probability of A given B is equal to probability of B given A, which is equal to 0. I will tell this as mutually exclusive. Okay, see, let's take up a small example here. So my A is D1 is equal to 6. B I have D2 is equal to let's say D1. I will tell that it is still D1 is equal to 3. Okay, if you can observe, if probability of D1 is equal to 3, what is the probability of D1 is equal to 6? Please try to understand this. See, already he is telling, consider this. I'm just giving an example for this, not this. Okay. See, he is telling if the probability of D1 is equal to 3, he is telling that D1 is tossed and it is giving the value 3. And still I want to find in the same dice D1, what is the probability of D1 is equal to 6? Is it possible?
No, sir.
No. Why? Because I have already fixed it as D1 is equal to 3. So how can I just go ahead with the probability of D1 is equal to 6? If it was D2 is equal to 6, so it was like it was independent probability. So since it is nowhere connected, it is not at all, it is exclusive. I will tell this as mutually exclusive. Okay, so this is one of the fundamentals which we need to know. So did you guys understand what is independent event and mutually exclusive event?
Yes, sir.
Yes, sir.
Can
Yes,
we
sir.
go further?
Yes, sir.
Okay, so now let's take will be trying to know. Now we'll come to your Bayes theorem. Okay, Bayes theorem with example. Okay, we shall try to see what is Bayes theorem, what it says. Okay, so what is the very first point I would like to tell? It is it includes your fundamental, it is the fundamental theorem in probability. So this you need to know. So in how did this Bayes theorem came into existence? So what is the history? So jotting down the history, in late 1700s. So in late 1700, it was the scientist name whose name was Thomas Bayes. Thomas Bayes. So who introduced your Bayes theorem? Okay. So this is the a great scientist who came up with this particular theorem within probability. So uh, so this whole theorem is named under this particular scientist name, which is called as Thomas Bayes. Okay. So after Bayes theorem, it is applied as naive Bayes. Okay, naive Bayes. I'll be calling it as naive Bayes. So what is if you just search for what is the meaning of your naive? Okay, naive Bayes. A naive means it is unsophisticated, unsophisticated, sophisticated, or you can call it as simplistic, simplistic. So this is the general meaning of your naive. So within Bayes theorem, so this is naive Bayes classifier means it is your simplest naive Bayes, how your Bayes theorem is applied to any concept. We call it as naive Bayes classifier. This is your NB classifier. Okay. So what is your, let's go ahead with now. So this is, let's say the theorem state that the theorem, okay, what does your theorem states that it is probability of a given b in which is equal to probability of b given a into probability of a divided by probability of b. Okay, if probability of b is not equal to 0, this is the condition which I am having. Please remember, this is your Bayes theorem. This is all your Bayes theorem is, and this whole module is discussed on this whole, will be dissecting this whole theorem, whole problem, or the whole formula, and will be trying to investigate each and everything which is involved over there. Let's go with the theorem first. So like what I have planned is, first I'll state the theorem. I'll go with the terminologies which I am having. Then I will prove the theorem, that is the proof. Okay. Then I'll go with the example. Okay. So this is how I go. Okay. So first I have stated the theorem. Next I'll be going with the terminologies which I am having. What are all the terminologies within that particular theorem? Then I'll prove how this came into existence, and then I'll go with some examples. Did you understand this?
Sure.
Okay. Now let's go with the terminologies. Okay. So let's go with the terminologies. What is the theorem states that? So theorem states that probability of, please repeat this when I am telling, you just repeat in your mind, probability of a given b is equal to probability of b given a into probability of a divided by probability of b. So this is the theorem. What is the condition? If probability of b should not be equal to 0. Okay. This is the theorem. Let's understand this term. Okay, I'll be calling this term as my term 1. This is your term 2. This is your term 3. This is your term 4. Okay. So this first term, that is probability of A, okay, probability of A given B. I will call this first term as your posterior. Probability of B given A, that is my first term in your equation, that is I will be calling this as your likelihood. Okay, likelihood. This term, probability of A, that is the product term which I am having, that is probability of A, I'll be calling it as prior. This probability of B, I will be calling it as your evidence. You need to know, because I'll be usually I'll be confusing, I'll be getting confused with all these 4 terms. This is your posterior, which I'm calculating. How do you calculate this posterior? First is your likelihood. This is your likelihood. This is your prior. This is your evidence. Okay. Please remember this concept. Remember. So as many times as possible, please just recollect this concept whenever you are, if your mind comes with Bayes theorem, you must understand this. Probability of A given B is equal to probability of B given A into probability of A divided by probability of B. I am having 4 terms here. What are all the 4 terminologies which I am having? One is your posterior, second is your likelihood, third is your prior, and fourth is your evidence. Okay. Are you people understanding?
Yes, sir.
Yes, sir.
Okay. So now let's say I'll just go with the proof now. Okay, let's go with the proof. Please note down the proof here. What is the proof for this theorem? Let's say, what is my LHS here? LHS, I have probability of A given B. So my LHS is equal to, LHS, I'll write down the LHS, that is probability of A given B. How can I write this probability of A given B? I can write it as probability of A intersection B divided by probability of B, or I can, this whole thing, see, in some of the textbooks or any reference book, few of them have stated like this: probability of A comma B divided by probability of B. Or it can also, in few books, it also been represented as probability of A and B. So I think it's not visible here. I'll write down it here. Probability of A ampersand B divided by probability of B. So anyway, some of the textbook might start with the proof. They can start with this or this or this. Okay. So what does it mean? Can anybody just define this term? What does it mean?
Probability of A given B.
Probability of A, capital A, happening. What is the probability of A happening and B happening? Okay, so this is how you define. Let's consider this. So we'll start with this. What is my LHS? That is probability of A given B, which is equal to probability of A intersection B divided by probability of B. Okay. Now, you know, in set theory, you have already studied this. We'll take this term first and this particular term first. Consider this term first. My A intersection B, can I write A intersection B is equal to B intersection A?
Yes, sir.
It is from set theory. So set theory states that A intersection B is equal to B intersection A. Now, probability of A given B is equal to probability of, I'll just change A intersection B to B intersection A. B intersection A divided by probability of B. Probability of B. Okay. Now, from this, so how do I write probability of, this is my equation 1. Okay. Now I'll just consider what is the probability of B given A? What is B given A now? Probability of B intersection A divided by probability of A. Can I write like this? Is it correct?
Yes, sir.
Sir.
Okay. Now you just, this is equation 2. Now you just cross multiply this. What you will get? Probability of A into what I am having here? Probability of B given A. Probability of B given A, which is equal to, what was the RHS here? Probability of B intersection A. Okay. Probability of B intersection A. So your probability of B intersection A, I can write it as probability of A into probability of B intersection A. So let's consider this equation as, what is the equation number 3? Okay, let's say it is 3. Now go back to the equation. See, in first equation I have probability of B intersection A. Can I replace this B intersection A by this whole term?
Yes, sir.
Okay, so I'll just replace with this equation. Go back to this equation. What I'm having here? Probability of A given B, probability of A given B, which is equal to, what was the numerator I was having? Probability of B intersection A. So what is probability of B intersection A? I'm replacing this whole term. That is probability of A into probability of B given A. What was the denominator in equation 1? What was the
Sir, I
denominator?
have doubt.
Probability of B.
Sir,
It is, yes, I'll come back. Probability of B. That is probability of B. This is your Bayes theorem. So this is your Bayes theorem. Yes, I'll just repeat it once again. Please listen to this explanation once again, so that if you have any doubts, you can just unmute yourself and you can ask me. So what is my Bayes theorem? I have stated my Bayes theorem as probability of A given B, which is equal to probability of B given A into probability of A divided by probability of B. Okay, so this is what I need to prove. So what is my LHS here? Probability of A given B. So I have taken probability of A given B. What is the, if I apply conditional probability for this, what is the formula which I can state? Probability of A intersection B divided by probability of B, which I can also write it like this: probability of A comma B, or you can write it as A and B. So these are all the various representation. So how do I read this? Probability of A happening and probability of B happening. Okay. So I'll just consider the LHS part. We shall start proving this theorem. Consider your LHS. What is your LHS? Probability of A given B. So I can write it as probability of A intersection B divided by probability of B. In this is your numerator, this is your denominator. I'll consider your numerator A intersection B. See, if I apply set theory, A intersection B is equal to B intersection A. So I'll just apply for this. Probability of A given B is equal to probability of A intersection B. I'll be writing it as B intersection A divided by denominator is same. So I'll call this equation as 1. Next, I'll go with probability of B intersection A. What is the actual formula for B intersection A? I'm writing this kind of formula here. That is probability of B intersection A. Okay, B intersection A divided by probability of A. So if I cross multiply this here, I will be getting probability of B intersection A as probability of A into probability of B given A, which is equal to probability of B intersection A. I'll call this equation as 3. Now, I will apply this whole value in your first equation. This was my first equation. I am replacing this whole term, probability of B intersection A, by your probability of A into probability of B given A, divided by probability of B. The same thing. The denominator is same. So this is your Bayes theorem. Now, if you have any doubts proving this theorem, you can just unmute. It's a simple theorem. I have used my set theory. That's it. There is no change, no further assumptions or anything has been made here. I have just calculated in this way. Any doubts, if you have, you can just unmute yourself and you can ask. Is there any doubts? Can we, have you people understood? Can just somebody confirm me, have you understood, or should I repeat it again?
Understood, sir.
Understood? Can few more guys just unmute yourself and you can tell me whether you have understood?
Understood.
Yes, sir.
Yes, sir.
Yes, sir. Understood.
Yes, sir.
Okay, okay. So now, we'll go with one example. Okay, what we have planned. So we have planned like, first I have stated the theorem. Next I have taken the terminologies. Okay, what are all the terminologies that we have here? Posterior, likelihood, prior, and evidence. Okay. Now, we just studied the proof also. We need to know the example now. So, okay. So now example, I'll be taking my example in the next session. Okay. So I think we can stop the discussion here. So I'll be discussing with the example in my next class. Okay. We'll be discussing this whole concept here in this. We shall try to take up with a very good real-time example. So we shall see how your Bayes theorem has been applied. We'll take up a Wikipedia example. We shall try to know. If you just go and type an example in Bayes theorem, we have a beautiful example. I'll just type an example. Bayes theorem, B-A-Y-E-S, Bayes theorem example. Wikipedia. See, Wikipedia is one of the beautiful website where you can just go ahead with many examples for Bayes theorem. Okay, so from any point of view, from statistics point of view, from machine learning point of view, or anything. Okay, you can just take up an example. We have these kinds of examples. Okay. So conditional. Okay. So this is the example which I'll be taking in discussing in the next set of sessions. Okay. We shall try to come up with good examples. Okay, so we'll stop our discussion at this point today. So in the next session, I'll be discussing about the example pertaining to your Bayes theorem, and we shall see what are all the constraints and what is chain rule, conditional probability, these kinds of things we shall try to discuss. Okay, thank you.